Hello and welcome to a special edition of the RØDE Video Podcast. In this episode, we're peeling back the curtain and taking you behind the scenes of some exciting innovations and new product announcements with a few of the key players within and adjacent to the Freedman Group. For more information on all the RØDE hardware and accessories that we're using to bring this video podcast to life, you can check out the links in the description below. But this special episode coincides with our appearance at the 2026 NAB show, which is April 18th to 22nd in Las Vegas. So if you're at NAB this year, we'll see you there. I'm Ryan Burke, Portfolio Director of RØDE, and joining me today is Dan Woodall, the Portfolio Director of Lectrosonics, Julian Kornprobst, the Senior Product Marketing Manager at Infineon, Karl Winkler, the Executive Vice President of Product Design and Distribution at Lectrosonics, and Peter Schillerbeeks, the Senior Director of Technology at the Freedman Group. Gentlemen, thanks so much for joining us from all corners of the globe. We've got people from multiple continents here and probably a combined experience of over 100 years in the audio industry, I guess.
Very old.
Yes. Is that a positive?
Not to call anyone's age or anything.
It's combined.
Exactly. I mean, look, for me, this is really exciting to be able to get everyone at one table to chat about some of these exciting innovations. And it's actually a pretty historical moment for the Freedman Group coming together with so many brands at the same time at one show to talk about a bunch of innovations. And I think we should start with yourself, Julian, as someone adjacent to the Freedman Group, not directly within it, with Infineon Technologies. Could you tell us a little bit about Infineon and your background with Infineon?
Infineon Technologies is a semiconductor company headquartered in Munich in Bavaria. That's also where I'm based. And we have a lot of divisions, right? So we're, for example, number one in automotive semiconductors. We do power parts, but we also do sensors and we do MEMS microphones. And this is also why I'm here today. We have our sensors product line, of which I'm a part of the marketing team. And we discovered that using semiconductor processes allows us to develop something truly great together with you guys, and very happy to talk about that today here.
So if we wind back, all the way to just, what Infineon does at a high level, you're talking about semiconductor manufacturing. For anyone who's not, kind of aware of what that even means, like what does, Infineon Technologies actually work on, and what does like all of that, kind of manufacturing technology allow you guys to do?
In essence, we make the parts that power modern life, if you so want. So you could say we're a chip manufacturer. That's probably what most people are more familiar with. But in essence, a semiconductor allows us to control all modern electronics, whether that's consumer electronics, a smartphone, or whether that's, let's say, a high voltage train running between France and Germany at 300 km/h. So we're involved in all of these parts. And in essence, a semiconductor, if you go down to the physics, you take a single crystal of silicon and you process it. That's in essence. Or instead of saying processing, we should say you functionalize it. You make it useful. You make silicon perform a function. Now, of course, I'm cutting it short. There's different types of silicon. There's now gallium nitride and silicon carbide. But in essence, you take a crystal and you functionalize it. I'm oversimplifying because if I say functionalize, that typically takes hundreds of process steps, a lot of time in fabs, and a lot of, let's say, expensive equipment. But in the end, you turn silicon into, let's say, the camera control for your smartphone. You turn it into the microphone in your earbuds, or you turn it into the radar that warns you when you're about to bump into another car on the road. So it's really everyday life is powered by semiconductors, and this is what we do.
Yeah. And I think what's really interesting, obviously in this discussion is talking about how that silicon, kind of based technology makes its way into pro audio for the first time as the actual microphone. So why don't we talk a little bit about a MEMS microphone, what does the term MEMS even mean, and what makes them different from a normal, condenser microphone that you would normally see?
So I think it's already in the description of the term MEMS, right? MEMS stands for micro electromechanical system. I know that's a bit of a mouthful, but in essence, it's nothing more than a silicon-based microphone. So you take semiconductor processes, as we said before, right? This single crystal, you process it and you make a really, really small microphone out of it. So the micro in the acronym MEMS is actually the crucial part. Now, a microphone, if you define it right, and you guys know this better than me. In essence, it turns acoustics waves into an electrical signal, right? That's that you can then record, and that is nothing new. I mean, the microphones have been around for probably close to a century now, if not more, and also good microphones have been around for a while. But to take high quality audio capture and turn it into a semiconductor, using a semiconductor process to manufacture them, that's where MEMS comes in. So we've seen now, if you think back, 20 years, I think, to the launch of this first awesome Motorola Razr phone, the super slim one that was.
I remember those actually. Yeah, I had one in high school. So.
Me too. Yeah, and it was amazing. I loved it. And actually, there was one of the first products that used a MEMS microphone. Right. So kind of, if you think about it, what was the value proposition of that smartphone? It was super slim, and you couldn't use conventional microphones to do it. So that's really the advent of MEMS microphones.
Right.
But if you look at the technology, the principle is simple. It's like the condenser microphones that are typically used. In essence, you have a capacitive system. So you have a membrane that moves. You have a charged backplate. You have a capacitance. And as air hits the membrane moves. And the change in capacitance is the electrical signal that's then read out as the acoustics. So the theory is quite simple, but scaling it up to your standards, that was, I think, one of the challenges that we worked on.
Yeah, absolutely.
How big is that? You talked about diaphragm, right? In fact, it's moving.
Yes.
And I think, we're all used to the idea of a thing you can kind of see. Like, how big is the diaphragm in a MEMS microphone? So
the smallest ones that are typically used are 0.8 millimeter by 0.8 millimeter. So very, very small. So micro.
I mean, it's just, I think that's just kind of what wild is the sense of, we think of diaphragms, 1-inch condenser mics, these big gold things you can look at, you know what I mean? Or even a condenser mic, a dynamic mic like this, having a diaphragm. But like that is, the diaphragm that tiny, and is that why it's hard to make it sound so good? Is that why there's a limit on why they've typically been seen as kind of low quality microphones? Is it just the size that's the problem because it's too small, or is there more to it than that?
Yeah, I just heard you said, that you used the present tense here. So I would say past tense. Yeah, they were seen in the past.
Yes, well, all right, of course, because we're going to talk about why that's now changed.
Yeah. No, exactly. but you're exactly right. I mean, it's always a trade-off, right? So you want the best acoustics, you want the smallest, you want the most precise, but of course you have to make trade-offs, right? And there's a reason why. I mean, we're talking here with large microphones because the acoustic pickup quality is perfect. I hope, if my voice sounds good, but since it's a Rode microphone, I'm sure of it. But fitting this into your pocket, that's a challenge. And this is where in the past, as you say, MEMS were struggling, I would say. So of course you can achieve audio pickup, but it needs to sound good, right? And that's a challenge.
I think it's a good point too, because a big part of what dictated the size of microphone capsules in the past was that, you wanted to have really low self-noise, you wanted to have really rich pickup, and having a larger capsule, you can actually get a really, really quiet, capsule in terms of self-noise. So you can have nice sensitivity to pick up sound, but it's not noisy with that hiss that you would hear on a lower quality mic. And I think that's where the intersection of, Infineon technologies with semiconductor manufacturing, working with the Freedman Group, with all of our audio brands, bringing pro audio tools together is really interesting because, for instance, we've been making, for how long now, the NT1A and NT1 series microphones, Peter?
30, 40 years, something like that. It's a very long time.
Since 1991, I think.
Yeah, and they've got incredible performance. But I think the interesting thing about MEMS technology is because people say, they don't sound good. And actually, they've always sounded okay. It's just that the noise floor was the real limiting factor. And I think this is about what we're announcing at the show. And this is the real breakthrough barrier because actually, if you look at the frequency response of modern MEMS, it's second to none. It's basically flat from DC to light, which is remarkable. And if we now add the really, really good signal to noise ratio to that, get a low noise floor, we're getting an incredible product that just was never possible before. So I think for me, that's the really exciting bit, because MEMS have actually sounded pretty good for a long time, but they weren't usable in professional kind of applications because they were just too noisy. All you could hear was this constant hiss in the background. And I think that's the really big breakthrough here, which is really, really exciting.
So I think we should, it's probably a good segue to actually name the product and what we're talking about today. And that is a new technology called Sonaura, which is a partnership with Infineon Technologies and the Freedman Group to bring the highest performance MEMS ever into pro audio. And the first silicon-based microphone that you will find in a pro audio setup that actually sounds incredible. Julian, did you want to take us through a little bit about your introduction to the Freedman Group and I guess the kickoff of this project that we have?
Yeah, it's actually good that Peter, you and Ryan, you are here because I mean this is how it started between us, arguably. So I remember when we met in Munich, it was just coming out of COVID times, or was still during COVID. Or you could just travel. I think travel started to pick up.
It just opened up.
Yeah, and we were actually in. I remember it was the Building 6209 second floor meeting room at Infineon.
That's a good memory.
It's a moment that has stuck with me, and like I think it was immediately clear that we had great potential to bring this to market, to finish, let's say, the development of this technology and make something great. And that's really what kicked it off. I think from that moment on, we knew we wanted to work together, and you saw the potential for bringing MEMS into pro audio, as you said, right? Yeah. Which was before not possible, or not. I mean, it was not usable. Maybe that's a word to say, because you don't want that hiss noise. Yeah. And we had those prototypes based on what we call the sealed dual membrane MEMS. Mm-hmm. So I was just explaining before, right, how MEMS is made up, right, with a moving membrane and a backplate and a capacitive system. But the sealed dual membrane actually takes this up a notch. So we're using two membranes that encapsulate a backplate.
And when you say a membrane, you're talking about, just for anyone listening at home, when you look at a large diaphragm microphone, you see that gold disc, and that's what everyone's singing into, and that's the diaphragm of the microphone, and that's the membrane.
Exactly.
And that's what you're talking about. That's the part that actually moves in sympathy with the vibration in the air, right?
Exactly. Except for when it's a MEMS, you actually need very good eyes or a microscope to see that, right? So you might be singing into it, but you don't know what you're singing into unless you take that closer look. But exactly, it's this membrane is a silicon membrane, or I mean, it's not purely silicon, but it's let's say a functionalized silicon, and that membrane moves. And by using two membranes, we actually achieve a differential system, so a bit of a more linear output. By encapsulating the backplate, or sealing it, as we say, we are able to almost create a vacuum, like a low pressure environment. So we get rid of a lot of the thermal noise by the air. And this is why the sealed dual membrane really gives you a super low noise MEMS that you can then, in combination with the other parts you need for a MEMS microphone, use to create such a low noise, professional grade MEMS microphone.
And in the Sonaura MEMS, we don't just have one of those sealed dual membranes, do we?
It's actually two. And because you asked before, so 0.8 millimeters typically, like this is on the smaller end. We're using 1.7 millimeter MEMS, two of them, to really get that sensing area up, because it does scale, of course, with the area, right? If you use smaller MEMS, you will have more self noise. So we maxed out the MEMS performance in a custom MEMS for RØDE, or a custom sealed dual membrane version, two of them. But that's only one part of the story, right? So the sealed dual membrane is, I would say, the star of the thing, because it's the sensing element. It's the one literally that's touching the air, right? But of course, that's not enough, right? So just a moving membrane doesn't give you a signal yet. So you also need, of course, an ASIC to read out the changing capacitance. And let's not forget also the design of the capsule itself, or the lid itself.
Yeah, absolutely. I think that was one of the funnest parts of that whole project. And I know, Peter, you would think so as well, as our Senior Director of Technology. But working with a semiconductor company, especially, Infineon Technologies, you guys make some of the best sensing tech in the world, and now the best microphone, silicon-based microphone in the world. The exciting part was making that,
It's been an incredible project. And this also goes back to Peter Freedman's passion for trying to make really small microphones that sound like studio microphones that have really, really low noise floors. So as soon as that conversation started, we got really, really excited. And I think the project kind of took off really quickly from there, given the size of the investment.
I think it's a good point too. You know, if you look at Peter Freedman, who owns the Freedman Group and founded it, his goal, you know, from being in audio for over 50 years has always been trying to bring, you know, the best tools into the market. And the start of that was making really good studio microphones that were very quiet, low self-noise, but could handle a lot of, you know, level. The NT1, NT1A, for instance, large diaphragm capsules are the quietest studio mics in the world. And you know, if we look at his vision to try to bring those tools, you know, into the hands of content creators, it just wasn't possible to get low self-noise into a small package because of the same challenge that you're, you know, mentioning even with MEMS. You know, to Infineon, a 1.7 millimeter diaphragm is very large. To us, when we're making 1-inch capsules, that's, you know, insanely small.
And coming back to that moment that you mentioned, right, when we brought those prototypes up literally from the first floor, you guys said, "Oh my God, this is so small," and we looked at each other from Infineon. We're like,
it was almost comical for you guys.
Who would call this small? Like this is a giant MEMS, you know. And this is, I think, but this is a good sign of how what you mentioned, right? That two worlds had to come together, right? I mean, us with the semiconductor, you know, specialized view, and you guys with the content creator and professional audio in mind, and I think that's what made it so exciting from the beginning, because you guys clearly knew what type of microphones you wanted, right? So what kind of performance a MEMS needed to fulfill to be called up to RØDE standards, right? And up to Peter Freedman's standards that he's been working with since founding the company.
Well, I think it was actually perfect timing. And I guess, Karl, this is where the Lectrosonics story comes in. Because at the time that we saw, you know, this technology, you know, that you guys had available, we actually had a project active at the time with Lectrosonics before they were part of the Freedman Group around bringing a really high quality lav microphone into the market. And that's why it was like an immediate connection for us. Karl, did you want to tell us a little bit about that project and how that came about?
Well, I mean, certainly the holy grail of tiny microphones. And, you know, I'm going to make a comment here about 1.7 millimeters. So it's a large diaphragm MEMS, right? Wouldn't you call it?
Yes,
true. Yeah, you could say that.
Yeah.
That's the way to sell that.
I love it.
But, you know, in our world, in film and television, you know, everything is hidden, and Broadway theatricals, things like that. And yet we're looking for really studio grade, you know, microphones and transducers to capture that sound, that performance, whether it's, you know, acting, singing, and then get it transmitted and received without any loss of signal quality. So it's starting from the beginning and going all the way to the end of the signal chain without restriction. That's always the goal. It's the holy grail. And it's really hard to do. Typically, you know, small microphones have always had that self-noise problem. And so it's a trade-off between how hideable is it with how good it sounds and the self-noise. So, you know, as soon as we learned about this project, you know, we're all very intrigued because we thought, hey, maybe we can look in this direction for something that would deliver, you know, what was impossible before. You know, there's been good microphones out there for years, and many of them are large. You know, we're talking about a very small microphone now, incredibly small, that can deliver that kind of quality. So, I mean, the project with Lectrosonics ultimately becoming part of the Freedman Group, you know, started out with wireless. You know, Peter, you contacted me and said, hey, maybe there's a way to collaborate on a project that would elevate the wireless experience. And then again, as soon as we learned about this technology, it was like, wow, we're starting to all have visions of great things that could happen with this. Again, the stuff that we make is typically used at the top of the professional level for Hollywood filmmaking, television series, Broadway theatricals, and things like that. And you have been involved very much with content creation, you know, which is, you know, a different experience. So there's a lot of different ways we could look at how this technology could be used. But from Lectrosonics' point of view, we could immediately see the value at the very top end of production of any type.
First time I'm hearing this. This is amazing. This is wow. I didn't know that that you guys were kind of talking in the background already about the MEMS that we worked on. And I mean, this is what better way to hear this acknowledgement than you mentioning this this behind the scenes. Thank you. Wow, that's
well, certainly. I mean, we've been approached over many years by a number of microphone manufacturers that have already been looking at MEMS technology, right? And our response has always been, well, the way we understand it, self-noise is a problem. And here's the kind of dynamic range we would be looking for. Here's the kind of frequency response we'd be looking for, and certainly the noise figure that we'd be looking for. And that always ended the conversation, to be honest. And so we thought, one of these days, that's going to be cracked. And apparently now it has been. So it was immediate interest on our part.
I think it might be quite interesting actually at this stage to talk a little bit about the performance itself of this MEMS, because it is absolutely remarkable. So if we look at the scale of microphones, if we look at large diaphragm microphones like an NT1, we get about 5-6 dBA of self-noise, which is extremely low. I mean, you cannot hear a noise floor.
The threshold of human hearing being, as a baby, on average 0 dBA. It doesn't mean zero energy at all, but that's typically the threshold of human hearing, right?
But in reality, there is no noise in any recording kind of environment, however quiet. And then if we go to really high-end, smaller pencil microphones that people might use on a Hollywood set or something like that, they're typically anywhere between 10 and 13 kind of dBA. And then when we get into typical lavs, anything is a go. We're talking 20 dB and up.
Plus,
and it goes up. And we're talking about high-end lavs at the 20 dB.
You say 20 dB.
With the new technology, the Sonaura MEMS, we're sitting at 11 dBA. That is absolutely earth-shattering. Yeah, that is really high-quality, Hollywood-grade, pencil microphone noise performance in the tiniest little
that you can
package.
Literally wear.
Absolutely. Yeah. And I think it's, you can't overstate how impressive that is. So we're really Karl, excited about that.
Your story when you first heard the first prototype, because I got some over to you, as soon as we had something that we could share and, that was actually really working. And I think just talk through what you heard. I think it was a great story.
Absolutely. So the envelope came, cut it open, and I typically don't let anything like that sit around, right? I'm like, oh, great, the microphones are here. Let me see. Let me get a transmitter. Let me get a receiver. Let's get a frequency. And, transmitters have a mic preamp in them. So, ours typically offer something like a 44 dB range of gain, to compensate for different types of mic sensitivities and things like that. Ideally, you want to have the gain set low so that the mic preamp doesn't contribute noise of its own.
Yeah.
And so a combination of sensitivity plus low noise is really, again, the holy grail. So I got this thing, plugged it onto our DSSM digital miniature transmitter, and started dialing up gain, and noticed right away that it was pretty hot. The microphone was generating a lot of electrical signal from just even room noise. So right away, great, I can turn my mic preamp down and have no noise from that. Then I started listening to it with headphones and noticed right away that there was an enormous amount of clarity. Then I just sort of set it aside and was, typing emails and listening to the background noise. And I started noticing that the background noise had a lot of detail. And that was what really surprised me the most, because I've used a lot of different lav mics, and that's typically not the case. And part of it is the self-noise. Like you said, 17 dB and 20, 23, those things are typical. So to have something like 11 meant it's 10 dB better, than the typical lav mic. And I noticed I could hear people down the hall talking. I could hear the water fountain turning on and off and things like that. And it just really struck me. So I talked into it more and listened more and listened more. And I realized this is exciting. I mean, I've been in the microphone business for more than 30 years, so I'm a little bit jaded. Dan and I were talking about that. We've been doing this a long time.
Everybody is in audio,
we've all heard all kinds of amazing microphones, and I've got a collection in my office of some of the best microphones used in film sets that are made in the world. And so I think I know what microphones sound like. So to be excited about this was like, wow, I'm excited about this. This is really something. So it struck me right away, no doubt. And I thought, let me get some more opinions. So we have a couple guys in our service department that have a lot of AV experience. So I gave the 2 samples to them and asked them to just listen to it. I didn't give them any comments. But they came back with a summary sort of report. It's very hot, but incredibly quiet and an enormous amount of detail. So they were also similarly impressed. So I figured, wow, we've got a hit on our hands with this thing.
It's probably worth noting that that is the upcoming L1 lavalier microphone for Lectrosonics. Very exciting to be the first microphone developed on the Sonaura MEMS platform. So
I think it just talks to just the quality of the Sonaura platform itself. You know what I mean? It's like there was a lot of opportunities. There is clearly it's, you're going to see this technology across the group in different ways. But as soon as we understood it, the first thought of where to put it was in the highest tier we have, selling to the highest tier customers in the group. Do you know what I mean? It's like
we're taking on Hollywood.
Yeah, absolutely. It's like, we're not messing around here. It's like, this is incredible, right? We're going straight to the top and we'll start there and work our way down. Do you know what I mean? Which I think is really, really fun. So yeah, and it's great for Karl and I because we get the excitement of being the first ones to launch it.
And do you know what? Not only are we taking on that market, but we're also outperforming every, other microphone in that market. There's nothing that it comes even close to having the self noise levels, matching that sensitivity and the other spec around the microphone. But that also leads me into one other point that you might have been going with there, Peter, which is the actual repeatability, product to product and the frequency response of that microphone.
Yeah, so in traditional microphone manufacturing, we have the most high-tech factory on the planet, basically. We can machine things down to 1 micron and so on and so forth. But the reality is with true condenser microphones, electrode-style microphones, we still have to test every single one, build it into a product, and then test it all over again. And with MEMS, we started with exactly the same approach. We tested every single one, but none were failing. And they were all hitting the same sensitivity, the same noise floor, the same frequency response. So that's huge because before we would have to, we've tested a batch, we had some failures, we move them to one side, so they never go to the customer. And we just don't have to do that with MEMS, and don't know if we'll actually talk about this much, but there are products in the works based on Sonaura that are of measurement grade quality. Yeah, so reference microphones, measurement microphones, because the repeatability is such that we don't even need a calibration file, which every measurement mic comes with a calibration file. So that's how good and repeatable things are. So I think that's another really exciting part for making these kind of products.
It's quite funny actually. I remember when we first got the samples of the first units and we did those measurements, I thought there was a mistake because we're looking at the measurement.
I remember that. Yeah,
and there was only one color, and normally you see every measurement is a different colored line, but they were all perfectly stacked on top of each other. So literally down to how thick the line was covering up all of the differences between units.
No, that's right. And when we sell matched pairs, and obviously anyone in the industry would know, matched pairs of microphones are a thing, and they have to be handpicked, and that's how you do it, right? Because there's that natural variation. Even the best professional microphones of a dB or 2 here and there, just across the frequency ranges. And so if you want to even you buy a matched pair, they're just the sort of okay, we've got them to within 1 dB by kind of more or less trial and error, but then to just literally be able to pull out like here's 200 MEMS on the table and they're literally all exactly the same, like better matched than any matched pair you could ever buy.
Exactly.
You know what I mean? It's really wild.
Yeah, almost look like a mistake, in the measurement.
Yeah,
it's like, where's the rest of the measurements? It's like, no, they're all there, just underneath that.
Is that intrinsic to the manufacturing processes? Yeah. So talk a bit about why that is.
Yeah, I mean, this is where let's say the beauty of semiconductor processes comes in, right? Because scalability without that, semiconductors also wouldn't be powering today's technologies, right? If you talk about hundreds of thousands, hundreds of millions of chips, you cannot have that variation, right? So this is inherent to semiconductors, right? It's a very complex technology, whichever semiconductor you make, right? There's a reason why we have to put up these 1.5-2 billion euro fabs, right? Because the equipment is very specialized, very expensive, but very, very good. So with the MEMS, for example, I mean, don't want to go into all the details, but there's probably hundreds of process steps involved in making that MEMS. But since they're so precise, the end product is basically the same no matter how many you make. And that's, I think, the scalability that you get from the semiconductor, or specifically MEMS technology versus other technologies, right? Where for sure with hand assembly, you can make the perfect microphone, but the scalability and the precision from part to part, that's let's say where MEMS really, really helps. And then literally in the end, for the testing, right? This is also something that was a development of the Sonaura project, right? Because typically, if you think about it, right, an assembly floor is always going to be noisy, right? And then talk about an automated back-end assembly. So you always have noisy machines, and that's a killer for microphone testing, because it's great to make a low self-noise MEMS, and then if you want to test for final specification, your machine on the left is also noisy. So we developed a specific test equipment, back-end test equipment to actually test the microphones for among other things, self-noise sensitivity, to really guarantee that whether you get 1, 2, a pair, 80,000, 100,000, 100 million, they're all going to be matched together without needing to hand match them. And that's also something we, for example, see in other industries where MEMS is now becoming more prevalent. So just a bit of an aside, the hearing aid industry, medical industry, also there. I mean, if you talk about hearing loss and helping with hearing loss, typically also there, microphones needed to be hand matched to get into one device. And actually MEMS technology allows you to also get rid of that step. So it's like an industry-wide shift, or actually across industries and applications enabled by this MEMS precision.
And so how does it, if we go specifically, the processes that are involved in making a MEMS microphone? I've seen a silicon wafer before, the disc of silicon. Like how does that work? Could you walk us through from having, the silicon, in its, kind of raw form all the way through to assembling that final microphone? What is that process?
So in the end, you can think of it actually imagining a block, like a round block of silicon, right? That's the crystal that you start with. And luckily we don't have to do this. We buy this because that's also a process, because you need, don't quote me on the figure now, I think it's 99.9999% precision in the crystal of silicon, right? So you cannot have any defects in the crystal lattice of silicon. I hope I got that right. I should as a chemist, but that's a long time ago. But you take those crystals, and as you say, right, you basically cut them into discs, and that's in essence your wafer, what we call wafer. And the wafer is, so to say, the canvas for the all these billion-dollar machines to do their magic with. And when you say do the magic, of course, we're oversimplifying, it's to functionalize the surface.
And that's the same wafer that would be used for a microchip or a microphone or a radar sensor. Or anything,
in essence,
right?
Yes, exactly.
Right.
So basically you start with silicon. The beauty of silicon being a semiconductor material is that as long as you have a pure crystal, you can basically make any electric functionality with it that you like. But you need to functionalize the surface, and that's what happens in many different process steps. Maybe you're familiar with the term lithography. So basically, a process step typically involves different etching steps, for example, or doping steps, where you functionalize or you bring ions into the surface, and then with photo stimulus, you etch away one layer, and then you do the next one. So in essence, it's you can think of it like stacking Lego blocks on top of that MEMS, and in the end, you basically have a functionalized silicon product, which is then in the end a wafer full of MEMS, right? So you take this disc that was before just a silicon crystal, and then in the end you have, depending on the size, 0.8 by 0.8 or 1.7 by 1.7 MEMS on that wafer. And of course you have many, right, for the scalability. So a typical wafer can have, let's say, from 10,000 up to 20,000 up to 30,000 chips or MEMS dies. And that is also the same then for the ASIC, of course. So your ASICs made in the similar processes, and these dies, what we call MEMS and ASIC, then come together into the back end, and in the back end they're assembled into the actual MEMS microphone that you then use in your products. Back end, you can also imagine it's in the end you literally glue the MEMS and the ASIC onto the functionalized substrate. Of course, you need the pins so you can actually read out the signal, and the lid to protect the MEMS microphone. And after all these steps, right, MEMS front-end assembly, ASIC front-end assembly, back-end assembly, we have our final test to actually, guarantee the functionality and the acoustic performance.
And that's that functional test is one that you were talking about, where you had to develop it specifically for Sonaura because the performance is so good in terms of its self-noise.
It's actually not just the test, but also the test equipment itself So I know if you've, as we talked before, right? Typically MEMS microphones, relatively high self noise. So for off-the-shelf testers, it's not really a problem, right? Because yes, your machine next to your tester is noisy, but anyway, if your noise floor is higher than that, you don't care. But with Sonaura, with such a low noise floor, this is how our test team had to develop an Infineon solution for that Infineon test equipment solution, and then a test program solution to be up to the standards that we set ourselves with Sonaura.
Yeah, no,
and it wasn't clear in the beginning. I do remember very early in the beginning of the program, our internal round, the whole R&D team sitting together, and one of the smartest persons I know in our MEMS microphone team, like the genius engineer, right? If he says something, you better listen. And I was sitting actually like us now. So you're that genius engineer. Well, you are, but a different one. And he was looking at me with his glasses and just raising his eyebrows when we talked about all the challenges that we have to face, as if to say, this is not as simple as you marketing guys might make it out to be. And but in the end, we made it happen, and we actually made it in the end better than we originally had hoped we would make it. So coming back
we kept pushing you guys to make it a little bit better. So I think to kind of show the difference between semiconductor and the traditional audio world is it was almost amusing in the beginning, because all that came out of the German engineering team is, we must have specs to this percentage in this 0.1 and this, and it went on and on. There was all these lists of specs, and all Ryan and I would say is like, yeah, but can we listen to it?
Yeah, that's true.
And it was a complete kind of clash of cultures. And I think that's the success of this project ultimately, is that we managed to bring that together. We managed to go through all the specs, and I learned an awful lot about MEMS that I actually never really wanted to know, and to get to the end of this project. And a lot of that was around specs. And we spent weeks looking at light sensitivity, whether that was actually going to be an issue for us. Turns out it's not. But, there's a lot of real fine detail we went through that, in making a dynamic cartridge or a traditional kind of true condenser or an electret. It's not the case, Yes, there is spec, but it's a lot wider tolerances and so on and so forth.
I think it's a good point around listening, and if we bring that all the way, full circle back to, the motivation behind making this. I remember that moment when we built the first microphone with Sonaura, very basic development board, and we had to get it in front of Peter Freedman, who basically kicked off, the entire company, and then the project of wanting to be able to create a silicon-based microphone. That first listen, was like the moment that really set it up. Like once we were happy with, the performance and the response, actually listening to it, with a pro audio context, and then, just the smiles around the room around having something that just sounded incredible was really exciting.
Because the funny thing about that prototype was it was huge. Like it was like a full-on huge studio mic, and then we had this foam windshield kind of covered over it. So it looked like you were talking into a large diaphragm microphone, and actually it sounded like you were talking into a large diaphragm microphone. I think that was the real aha moment, kind of going, okay, all of those specs that we've been painstakingly going through are actually starting to kind of turn into reality here as soon as we heard it. So I think that was really cool.
That was my experience as well. I mean, I thought right away, it sounds like a studio microphone. Yeah. You would never imagine it's something that's 5 millimeters.
Did you tell Peter that it was a MEMS when you first showed it, or was it like, hey, here's a mic, just try it, and then you kind of took off the shield and
the big reveal.
Voila, it's a MEMS.
I think he knew.
Okay.
Hey, there's one more, I think, really important thing which we haven't really touched on, and I think that the MEMS allows us to do. And Karl, you might want to kind of elaborate a little bit on that. But there is one key feature about this lav that the MEMS is making possible that we haven't actually talked about. So,
let's talk about the waterproofing.
Yes.
I've been trying to get there.
That's a very good point. Right. This is the most exciting part about this project. Is not only is it the highest performing lav microphone, but it's also completely waterproof.
Well, back to the sealed dual membranes, the key word sealed there, but that's how we're going to demonstrate it at NAB, is with a little bit of fun, is to have a robot arm that's dipping this thing in and out of water along with our watertight transmitter to show that the whole system that could be on the talent is completely sweat-proof, completely waterproof. And that's definitely something remarkable.
I mean, there's a backstory to this, which starts with Lectrosonics anyway, because the whole requirement for a waterproof microphone seems, on one level, seems very niche, right? Who needs a waterproof microphone apart from people doing kayak channels on YouTube? But in reality, at the high end of the business, it's actually really important, because you're hiding microphones and transmitters on talent on stage. And if you've been to any West End or Broadway musical, they are hot environments, and these performers are dancing and running about, and they literally sweat inside these costumes like buckets, So any electrical or audio equipment you've got strapped to that performer, hidden underneath their costumes, gets wet. Not just like, a bit of dampness, like it's literally just sweat pouring off these performers the whole time. And so solving these what's called sweat out issues, whether it's the radio pack that dies, or whether it's a connection somewhere, or whether it's a microphone, is really critical. And so over the past few years, Lectrosonics has been tackling this and has launched the DSSM, which is a completely waterproof transmitter. So this was like a big breakthrough, for Lectrosonics. It's the first IP67 certified waterproof wireless transmitter in the world, and you can just literally put it into a bucket of water, and it continues to work underwater. But the reason is not because people want it for kayaking, although if you do kayaking, you should definitely get one. But it's
there's a lot of fishing shows reality television.
No question. Reality TV, people get thrown to swimming pools. But I mean, certainly in that theatre business too, it's really important. But of course, that's great. We had the waterproof transmitter, and that was answering, sort of half of the problem, which is like when my radio packs get wet and get water inside, and they short out, or the battery shorts, or it stops working. But then there was always this bit missing, right? It's like, well, that's all very well, but what happens when the mic gets wet? And when a traditional lavalier, like, sort of a electrode or condenser gets wet, it starts to crackle, it starts to, sort of stop working. And it's not just like, you need to get the water out, because once water's in there between, around the diaphragm and the backplate, it starts shorting out the electric, that capacitive circuit you talked about, and it kind of doesn't come back to life. And so then the whole point about having this application for that high end, which was like, no, this lav doesn't work like that. If it gets water in it, it works. It comes back. It keeps working underwater, actually. You know what I mean? And you can just sort of, clear. There is water, just a huge blob around it. That might have a small acoustic effect, just because the water's kind of blocking the sound, like when you get water in your ears. But as long as you can flick the water away, and it's immediately back to 100% performance. And that's another huge benefit of this. Leaving aside the sound quality and all these other things, it's like, and that as well. You know what I mean? Which is why it is the holy grail. You know what I mean? A mic that sounds that good, with that low noise floor, that's hideable, that's that small, and is impervious to water. Like, this sounds like magic. You know what I mean?
And it's true. I've seen the video yesterday, actually, of your demonstration that you're going to show at NAB.
Yeah.
And it seemed magic, and I can only encourage everyone who is at NAB to go check it out, because it must be amazing in seeing it for real, because already the video was amazing. And what you just described is such a great example of how us working together created something that's where 1 + 1 is really more than 2. So we had that very technology, but you have your understanding of the value this can bring, right? So we talked about acoustics all the time now, but this making something, like you say, that actors, have this sweat in problem. Now you described it, of course, seems totally reasonable, but I didn't think of this before, right? So turning this platform and making it useful to so many applications. I think this is how the magic really happens, working together as a semiconductor company and a pro audio content creator company. Yesterday night I was lying in bed, because anyway, thanks to jet lag, I couldn't sleep, but I was thinking about this. It's amazing what you guys have done with this and are showing.
Yeah, I think if anyone is attending NAB, please do come by and see the demonstration. And what they'll see is the microphone and the belt pack completely underwater. And Karl, that's something that Lectrosonics has been doing for a long time, right, with the DSSM?
It has. The DSSM was preceded by the WM, and before that was the MM. And so we've been, for the last 20 years, been making watertight transmitters. But the difference with the DSSM is the fact that it takes a standard connector, because before we had to make our own proprietary microphone connector. And so companies that had lav mics would have to buy these kits from us for the connector and all that. Now it's a standard LEMO 3-pin. But also in the past, those transmitters, you had to have the mic connected via that proprietary connector for it to be watertight. And now it's watertight even without a mic connected or an antenna. So completely watertight, and you can open it, take the battery out, put another battery in. It's got a lot of nice features. So we've been doing it a long time. And, some of it is what Dan has talked about. Certainly the the need to protect from sweat and just water in the environment, things like rain or, the pool scene, like you said, about reality television. But there's shows that specialize in water as well. I think Cirque du Soleil's got a number of them. The DSSM is used for Harry Potter London on the West End because they do some magic on stage, and some of that involves the actors getting in the water. So they've been using the DSSM for that reason. So now to add the microphone to that equation means that, it's going to last longer, it's going to sound better, it's going to hold up where nothing before has been completely satisfactory in that regard.
And you think about, especially a live theatre show, you've got how many people in the theatre, they've all paid to be there to enjoy a show. And it's mission critical that microphone amplifying their voice for the actual performance is working the whole time.
That's right.
And you can imagine how many, nervous sound engineers there've been over the years, as people are getting wet or even, sweat. And that's why you often see, dual microphone redundancy and things like that. And now we've got a microphone that can survive all of that. So.
No question. It's something they've asked for years. And, durability is their number one concern. And they want it to, of course, sound great, but it's almost like there's a little bit of a trade-off between the durability and the sound quality. And I think we can address both of those issues.
Absolutely. Now, Karl, we've been talking a lot about Lectrosonics in the context of Sonaura and the new L1 Lav. But why don't you take us through a little bit about Lectrosonics, what Lectrosonics means in the pro audio industry, and even a bit about your background and how you joined.
Sure. Well, I joined the company 21 years ago. We had a little get-together last night in Sydney with some local sound mixers that do television production, movie production, and so on. And one of them asked me, what was a new product when you started? And I said, the UM400A, which has long been discontinued, but was a product that we made for 15 years. And, our background was in, audio amplification, until the mid-1980s when we realized that the future of sound in the professional world was wireless. We had a president at the time that kind of had that vision, John Arison. And so we invested heavily in the development of wireless that would be as small and portable as possible, running on batteries, but still deliver really high-quality audio and be really bulletproof on the wireless side. And at the time, these were single-frequency crystal-controlled units. You couldn't even tune them to change the frequency. But these work so well that news crews started adopting them right away. And not long after that was movie sound techs that, heard about this idea that, wow, there's a portable wireless system that sounds and works as good or better than anything that came before. So by the late 80s, with our CR185, and in fact, a couple of the gentlemen last night were talking about that they still have them and they still work. These are CR185 systems from the late 80s, early 90s, and they still work. So we got the reputation of having really durable products made in the U.S., made out of metal, with a simple user interface was the idea at the time. And that was built upon mainly by the relationship that our engineers and our company leadership had with these sound mixers. So I came along already in the sort of middle of this period in 2004. This is before digital wireless really had any footprint. The units they were UHF, but they were tunable, but still limited interfaces. And in that time, the technology's changed a great deal because now we have color displays. We have, instead of 256 frequencies to choose from, we offer units that have 6,000 frequencies to choose from. And a single portable unit back then was one channel. Now we offer something in the same size that has 4 channels. So the density of the technology and how much flexibility it has increased dramatically in that time.
And the target, kind of application for most of this technology, like could you talk about, the typical Lectrosonics customer? Sure.
I would say the typical Lectrosonics customers, we have maybe 3 areas. One of them is going to be broadcast audio, where you might have let's say a news studio, and they need a system to be able to listen to cueing, and then wireless microphones that the talent might wear. And that's when you see like the 2 labs, like you said, redundancy. Another customer profile would be anything that's mobile broadcast, including what we call ENG or electronic news, meaning they follow the action. There's a train derailed here, and we're going to go look at it, that sort of thing. So that means the systems need to be portable, lightweight, easy to use, and bulletproof. So those are, again, the portable units that we mentioned earlier. We still make that sort of thing. And then there is the sound mixers as definitely a central type of customer for us, which means the independent mixer that gets hired to do a film or TV or commercial project, and they have their own sort of portable studio in a bag or in a cart, and they bring it with them. And in there is going to be some kind of field mixer recorder, as well as wireless receivers, and then they have transmitters to put on the talent, as well as a fold-back or queuing system that they bring with them. So, the demands there are that to have the absolutely pristine quality, to do movie production. Think about the dialogue. When you're watching a movie, that dialogue has come through either a wireless system with a shotgun microphone or lavalier microphones going to body pack transmitters. And it's got to sound absolutely like they're in the studio, clean, quiet, crisp sound. And, again, in a very portable format, to think, someone today could have 8 channels of wireless receivers, 8, channel recorder in a bag that's this size, powered from a battery.
Yeah, it's incredible. And you mentioned before how your systems, have been used in West End, on the Harry Potter shows. Are there any other, really notable productions that you're aware of, where Lectrosonics has been integrated, and anything you're really proud of having seen over the years?
Well, certainly a lot. Staying with theater for a second, our units are used in a number of Broadway tours and shows. I mean, we have been used for Frozen and Lion King, tours, Hamilton tour for remote speakers, we're Pretty Woman, King Kong, Beetlejuice, many Broadway top level, shows that relied on Lectrosonics wireless. Probably what we're most famous for, again, is film and television. So we can say that 10 out of the last 11 movies that won an Oscar for sound were using Lectrosonics wireless.
Wow, that's incredible. Yeah.
Yeah. So it's a lot to be proud of. And, so much of it comes back to those relationships that we have with those customers and the feedback loop. Something we heard last night at the gathering was, you guys really listen to us, and we can't always do everything that everyone asked, but we work really hard to do everything possible and practical that they ask. And a lot of it's features, and it's also, they want it to have a certain range, to be, as long as possible, yet be light and battery powered and still sound like you're in the studio. And that's what the digital wireless stuff delivers today.
I think that really resonates. I mean, for us, like that shared DNA of companies, when I started out with RØDE microphones, within the Freedman Group, and, that what you said around, Lectrosonics really listening to the customers, that's always been, a foundation, for RØDE to be able to listen to content creators, which was our, kind of area, as well as musicians in the studio, and try to bring the tools that they really needed, not just, making another product, similar to what was in the market.
Right.
Probably segue over to you, Dan. You've been, with RØDE microphones for quite a while, and now, with Lectrosonics in the Freedman Group. Can you tell us a little bit about your background and also how you came to, be involved with Lectrosonics within the Freedman Group and what that's been like?
Yeah, I mean, I've been involved in the audio industry for, very, very long, way too long, I suppose. And I've worked.
I noticed you didn't put any years. Strategic move.
Yeah, that's right. Just draw a veil over the number of years. So yes, over a number of years. I've worked for, various companies across the pro audio kind of industry. But some of my first experiences in the industry were, funnily enough, in high-end wireless.
Right.
Right, for some of the sort of, other big brands in that kind of space. And then I sort of, went away, did a few other things, and then, came back, ended up at RØDE about 8 years ago, which is, a really exciting place to be. And I was looking after marketing and then some sort of elements of product development. And so, it's been an incredible journey, with RØDE and the Freedman Group, seeing that brand sort of come to life. And actually also did work with Soundfield as well, which is, of course, another sort of high-end niche brand in the group. But then the whole sort of story of how this came about, I mean, we touched on it earlier with Lectrosonics, but, this all came about from the two companies chatting about different opportunities for working together. Okay, so Lectrosonics and RØDE were in conversation about a number of potential collaborations on technology, where we could share, sort of resources, or we could, co-develop products for however that might look. And as those conversations kind of continued, everyone just kind of like, I think I said last night, we just, we might as well just get married, because it was all just going so well. Do you know what I mean? And so that it ended up, although it wasn't planned like this, it didn't start out as some sort of, acquisition or some sort of thing. It was like, hey, we want to work together. And it ended up going, well, it actually makes most sense just for Lectrosonics to become part of the Freedman Group. And then so obviously Peter acquired that company. But it was kind of very mutual. It was kind of a really happy arrangement for everyone. Because I think what was really interesting about all those meetings, and you touched on it just then, is how similar the companies were. And you wouldn't imagine on the surface that would be the case. You've got, Karl's just described, the customer base of Lectrosonics, these sort of highest tiers of, the industry up here, which seems a very long way away from the sort of musicians and content creators, the mainstay customers for Rode. But the philosophy was actually really similar about how you understand who the customer is, you understand what they need, and then you use your, you have in-house development teams, you have in-house manufacturing, and you iterate and you go through processes to understand what people want, and within whatever the parameters are of that customer or that market you operate in, you do the absolute best you can with no compromise. As you said earlier, just keep pushing like you were pushing Infineon. You can do better, 1 dB more, and it's always the same for Lectrosonics and for Rode. Very different customers, different products, different context, but that idea that it's never enough just to be good. You've got to be striving, and you can always find ways to tweak more. And so the fact that these two companies were quite similar was kind of like why this all suddenly made a whole bunch of sense. And then once, of course, the acquisition happened, came into the group, and then we could really sort of open the books properly. Because I think up until then, these conversations were really exciting. It's like, we just want to be able to talk properly. And, you can't, this commercial sort of, in sort of considerations around those conversations.
Certain holding cards close to the chest. Right.
Finally we can all talk, and all the engineers kind of started talking. I mean, you got to chat with David Thomas, sort of the lead sort of engineer at Lectrosonics, super smart guy. And, we got to talk about the Sonaura project, and we got to talk about, sort of the wireless that was happening at Rode and how all this could all come together. And like everyone, all the engineers and all these, it's just so exciting to watch everyone, just light bulbs going on all over the place, around, wow, there's so much we can do now with a
bunch of engineers becoming best friends across the company.
Getting married. I mean, it's the best type of shotgun marriage I've ever heard of. I mean,
you know what I mean? And very complementary skills too. Actually it's quite interesting, even like just looking at the differences between Rode and Lectrosonics, is like it literally was super complementary, even down to the manufacturing. I mean, I joked the other night, right? Rode is very good at making round things, Lectrosonics is very good at making square things, even down to like, the sort of machining that we have, it's just kind of very complementary. So it's been really exciting. And then when, of course, this was all starting to sort of come together with partnerships, and when there was some discussion around acquisition, I kind of got wind of this, and obviously I have a background in that, very interested in that part of the market as well. And I was kind of like, hey, me, can I be part of this project?
Yeah.
It'd be really cool. And so now it's been really exciting to take that on. It's kind of be Karl's kind of counterpart in Sydney. So I represent the brand, at HQ, and sort of obviously making sure from a product development point of view and a commercial point of view, there's a voice, in HQ, and obviously work very closely with Karl, and then that allows that collaboration across the group, which is really cool. So it's been like super, super fun. Yeah. And like, a real opportunity for everyone, I think. Yeah.
What about on the other side of the fence? Like, how was that for the Lectrosonics team, getting, into a situation where you're becoming part of a new, larger, audio group?
Sure. I mean, there's a learning curve, but I thought, at the time, just as Dan describes, it's sort of like, wow, there's a lot of possibility here. And I think that, we didn't know that much about Rode, to be honest. And so they brought us out to see the factory and to go to meetings and start kind of talking strategy and product group, families and things like that. But all of us were awestruck by the manufacturing capability here at the Rode headquarters,
Not just you.
Yeah. and we're also proud of our own manufacturing. As Dan said, we've got certain expertise that, was different in different areas, and we love bringing people through our factory, and most people are very surprised at like, wow, it's like you really make everything, and we do. So, but Rode is sort of Lectrosonics writ large. In fact, I remember Peter Freedman saying, wow, the Lectrosonics place, it's like Rode just a few years ago, before we really expanded. We noticed some types of manufacturing capability and technology. For instance, their molding, the injection molding that's done here is just mind-blowing. There's a machine shop dedicated to making molds and tools that's as big as our entire machine shop, for making our products. And some of that is the volumes. We're making high-end, sort of low-volume, almost semi-customized products, and Rode is making much more high-volume, products. So therein lies a difference of approach in manufacturing. But again, a good amount of overlap, a good amount of complementary skills. And then, the engineering focus too is Rode is focused a lot on designed for manufacturing. How to make it efficient, how to make it easy to use. You've done an amazing job of making interfaces for products that on the inside are complex and what happens, but yet for the user, it's sort of turn it on and it just works. Which is not something we've particularly focused on. We focused on the professional user that, can handle a certain amount of complexity, and we try to make that as easy as possible with, menu structures that look consistent across the board. But, bringing these ideas together is like, wow, there's a lot of things we can each learn from each other. And that's absolutely what's been happening. But from product management, Dan and myself talking, to engineering talking, to, manufacturer specialists talking. It's been an amazing collaboration.
Yeah. And I think the exciting part here is that it's not just talk. Obviously we're bringing out the LAV, but we're also launching RØDE's first UHF project or product that is very much based on Lectrosonics UHF technology. And I think that's
a great segue,
right?
Exciting, because this is the first UHF project. Peter Freedman's been wanting to create the UHF microphone for a very, very long time. Obviously in the content creation space, we kind of dominate that 2.4 gigahertz wireless microphone space. We started it, we own it. But we are also aware that if you want to take a step up and you want to start making higher quality productions, the robustness of UHF, kind of the lack of body blocking issues and all that kind of stuff.
And the ability to assign a specific frequency, so and that's your frequency. Yeah. You don't have to share it with other devices. Yeah.
So we're bringing all of that knowledge together with all of the Lectrosonics knowledge, and we're launching our first UHF product at NAB, which is very exciting. It's called RØDELink II. The first RØDELink was 2.4 gig. The new RØDELink is UHF, so it's all sub 1 gigahertz. So you get enormous, range, great performance, and we'll be showcasing that for the first time at NAB, which is really, really exciting. So that's behind the scenes what's been happening. And I think also to Dan's point is the reason we started talking to Lectrosonics in the first place was who is the best? Who is the best at UHF? Who makes the Rolls Royce of UHF? So we ended up talking to Lectrosonics, and that's how it all started. So, rather than going, we need some average kind of UHF, that's not how this project started. We wanted to start with the best, so that's why we ended there. And then obviously it snowballed into something completely different and very exciting. But now we're launching the first product based on that whole partnership. And it's been a great journey, and it's been developed across, 3 different continents, so it's being developed here in Sydney from a mechanical point of view, from an electronics manufacturing point of view, design for manufacture, UI, UX, and all of that kind of stuff. Then we have all of the UHF technology, being coming from the Lectrosonics team in Rio Rancho, in New Mexico, in the US, which is very exciting. And then we have a team in the UK bringing together all of the software around that, and actually introducing some new features that are very, very unique to this product, and kind of layering that on top of the whole Lectrosonics technology stack that we're using. And to Karl's point, it's all about making life of the user easier, making it less complex. Because I think one thing about UHF is it can be daunting, it can be complex. So, with this new product, we really want to make it pretty much plug and play. And that's kind of what we're doing with this product.
I think that is the perfect intersection of, RØDE with that, kind of the customer base, where we're often bringing them into, pro audio and having tools that are really simple to use but sound amazing. And then Lectrosonics bringing the best, most robust technology together. And I think that's a very good point. You've got the first really user-centric UHF system that's designed for anybody to be able to use. Dan, you could probably talk a little bit about that project, the RØDELink project, because I know that you've been involved in that for quite a long time.
Well, yes. I mean, I was. And interestingly, the need for that product emerged, quite some time ago. And the initial thought was that it would be an extension to the 2.4 gigahertz, range that we had. And as that kind of, that project progressed, it sort of became clear that was not going to be good enough. Do you know what I mean? For the type of user that we were looking at. we would have to look at UHF. But what we also found was when we went to meet some of these users who needed UHF, from a practical perspective, but they were not, they weren't Lectrosonics customers. These weren't people with that level of, expertise, or, they weren't specialists in audio. They were obviously, in many cases, people doing camera work and lighting and sound, and they didn't have time, or, they didn't want to have to go through the learning curve of, really getting into the guts of what UHF was. They just needed something that they could turn it on and it would work. Do you know what I mean? And that's always been a challenge with UHF. There's always been this kind of steps of, setup that you sort of have to typically go through. And so being able to sort of, how do we solve that? Do you know what I mean? And they were sort of like coming at it from a UX, UI point of view, like how do we overlay, that? Some of the new sort of stuff that we'll probably talk about in a minute, introducing a whole nother level of communication between the different devices, using a whole new comms platform to have bi-directional communication going between the devices, which is what we kind of learned from the 2.4 gigahertz stuff we did before, just how valuable it is to have, sort of bi-directional communication. But then layering over that, the best UHF in the world, because it just has to work all the time. That's the other thing. Do you know what I mean? Like having the best UHF in the world isn't just sort of like, a vanity thing. It's kind of like, well, if people want it to be, in order to be easy to use, it has to work brilliantly in a weird way. Mm-hmm. Because otherwise you're asking people to figure out for themselves how to make it work. Because
it's not easy to use.
It's
anymore,
not easy to use anymore, right? Yeah. So you kind of have to have incredible performance to make a product easy to use. I mean, it's kind of seems weirdly counterintuitive. So that's kind of how all this kind of came about. And so hence now there's this, to Peter's point, there's a number of different technology stacks that kind of sit in that RØDELink II project, in that product, which represent different parts of the company. Do you know what I mean? And different parts of the group. There's that UHF, which is, comes, it's not a direct replacement. It's not the Lectrosonics thing directly dropped inside, but it's all the DNA of Electrosonics, sort of UHF, built by Lectrosonics and designed by their engineers, to our specifications. So we know it has that rock solid side. It's that kind of usability and that kind of sort of ease of setup, and we get from the 2.4 gig and having talked to our users so much. And then there's the new side of it, which maybe Peter wants to talk about, which is the whole back channel communication. There's a whole kind of communication mesh layer that sits over the top of this, operating at a whole nother frequency.
Yeah, so that taking a step back, if you look at a wireless Go product or a wireless micro product, it's either comes prepared from the factory and no one ever really needs to repair it, or it's literally single button press pairing. And the thought was, hey, how can we keep that usability within the UHF space? Because the traditional UHF usability, it's literally you have to type in a frequency on a little screen, and then you have to do exactly the same on the bell pack or the handheld microphone, and then you have a listen, and then you go, okay, that's good, that sounds all right, hopefully that will be okay, and then there's all these other kind of configurations, but it's always a two-stage process. I have to do it on the receiver, I have to do it on the transmitter, hope it's all good, and then we go. So what we decided to do was actually, no, we want single button pairing, which is kind of counterintuitive in the world of UHF because you don't know what frequencies you got to be on and so on. So we pair, like you would a wireless Go, a transmitter or multiple transmitters to your receiver. And then we have a fully bidirectional back channel, what we call communication link, that is low data rate. So this is for messages like start recording, turn your RF on, mute, change frequency, all of those kind of tasks. And we thought, great, we have a really good solid back channel in our 2.4 gigahertz platform. But then we thought, well, but we want it to perform actually as good as, or not better, or if not better than the UHF audio performance. So we had to completely rethink the whole back channel comms. So we're actually in that same sub 1 gigahertz band. We're stealing a tiny little bit of spectrum to have full bidirectional communication. We're then linking that to an intelligent frequency detection, so you can scan all on board. You don't have to use a separate app or anything like that. Good frequencies within the ranges that you're allowed to use within your region or the ranges that you've set. And it will then basically map those to the receive channels, send that across the comms channel to the transmitters, and we're good to go. But I've said a lot of words and I've described a quite complex thing, but to the user, all they really did was press two buttons and they were paired. And actually, once they're paired, they will never forget each other. So you most probably only have to do that once, and actually they'll come prepared out of the factory. So you might never have to do it.
So unless the user wants to specifically define frequencies to transmit on,
absolutely,
it's basically turn it on, pair it, and then forget about it.
Yes, basically that's the idea. And of course, there is a complete manual mode. But even in the manual mode, because we have the back channel communication, you only have to do it on the receiver, and the transmitter will just follow. Yeah, so that's really, really nice, and it makes the usability a lot easier. And of course, we allow for all those different workflows, because you might be given a frequency, you have to use this frequency because there's a lot of people here, and there's nice frequency coordination. You just type it on the screen and off you go. So, but it will always be automatically sent to the transmitters, which is really, really powerful. So we're very, very excited about the launch of this product.
And people can come and see the RØDELink II at our NAB booth, can't they?
They can indeed.
Can I just ask, you mentioned before, this was Peter Freedman's wish, right, to get into UHF, and that's what started the cooperation between RØDE and Lectrosonics? Is that?
I think it goes way, way, way back. I mean, I think Ryan, interestingly enough, we were having a conversation with Peter Freedman only 2 days ago, and he goes, he's a collector of great, audio gear dating back to the 60s and the 70s, and he pulled out a wireless system. I think was it the 60s? A Vega wireless system, and it's one of those single large, big dial on the front, and that's when his passion for UHF wireless audio, it might not even be UHF, it might be VHF.
Very likely
VHF. Yeah, definitely.
So, but that's kind of when his passion for this started. So this is going back 60 years. This is like really, really been there for a long time. And then as the business has been growing, we're kind of going, okay, we're the king of 2.4 gig wireless. Let's now really start looking at UHF. And that's how the reach out to Lectrosonics happened, and that's how we got here in the end. We ended up acquiring Lectrosonics, and, we're now developing this first product. And I can't officially say that, but there might be more in the works.
I wonder.
What could it be?
Could it be?
So we'll leave it there for now and take a quick break, but don't go away. Please join us for part 2 of this episode. The link is on your screen now, or you can find it in the description below.